In this video, we're going to focus on the domain of a function, and then we're going to look at composite functions and the difference quotient. Okay, so we've talked a bit about domain already, and we kind of looked at it from a graphical standpoint. So now we're going to look at it from a formula standpoint. By just looking at the formula for a function, we'll be able to kind of think about what the domain is and what's allowed to be plugged into a function and what's not. So that would be the kind of the informal definition. What's the domain of a function? The set of all numbers that I can plug into a function without having any issues. Okay, so you might remember that you can't divide by 0, right? That's one of our domain issues, our first domain issue. So this is a function for total cost, but it's not going to make sense when x equals 0. X being the total backpacks produced. Okay, so we'll also have to consider domain for an application problem, right? So if there's no application to this, you say, oh, I can't divide by 0, so the domain is x cannot be 0. In interval notation, we say, well, we start at infinity, go to 0, and we skip 0, and we go to infinity. This is interval notation. This big U means for union of these two sets. This set is from negative infinity to 0, and this is from 0 to infinity. Okay, but for this application, that's if there's no application, this is the domain. But with the application, what makes sense? Well, negative backpacks doesn't make any sense. Okay, so the domain of this problem would just be, in the context of the problem, for the actual application, would be 0 to infinity, not including 0. All right? So a couple things to think about here. Without an application, you say, okay, what are my rules? So we're going to look at a couple of rules. Can't divide by 0, and you can't take the square root of a negative, right? The square root of a negative number isn't real. We'll talk later about what a complex number is, but for right now, this just doesn't make sense to us, right? Because I can't square a number. The square root of positive is 2, and by definition, that's because 2 squared is 4. But it doesn't work for negative 4, right? Because you might say, well, maybe that's negative 2. But if you square negative 2, you're always going to get positive 4. Okay, you always get a positive here, not a negative without the imaginaries. Okay, so that's the reason why I can't square root negative. So we'll look at this function and determine how to figure out what the x has to be in order to have a real domain. And then this one is you can't divide by a 0, which I already mentioned. I didn't really explain it, so there's a couple ways I can explain why you can't divide by 0. But one thing is, let's look at an even simpler function. Why can't x be 0? Well, here's one explanation. Let's get really close to 0. This is kind of like a calculus approach to it. Let's get real close to 0. Well, give me a number close to 0. How about 1/100th? All right, so we look at what happens when I plug in 1/100th. How about 1/1000th? That's 1 divided by 1/1000th. Okay, so as a fraction if you want, which is divided by a fraction is multiplying by the reciprocal. So that'd be 1 divided by 1/100 is 100. And you can see what happens. The closer I get to 0, right, this is closer to 0 than this, then the next one you could say 0.0001, right, and that should be 10,000. So you get this weird behavior. You can't ever get to 0. The closer you get to 0, the crazier your outputs get, right? This is called, there's an asymptote at x equals 0, which we'll learn later in the semester. So my 1/x function looks like this, if you were to graph it, which we'll learn about later. So as x goes to 0, it goes really big. The output y goes to infinity. Okay, so you'll never actually get to 0. You can keep trying, but the closer you get, the further away you go up in terms of y. Okay, So that's an easier case. What about something like this? If you have something more complex in the denominator, well, remember, it's the whole denominator can't be 0. Okay, so hopefully the understanding here kind of makes sense. Okay, but what you need to do algebraically when I ask you this question, what's the domain, you have to find the bad values. Okay, that is x minus 5. If you set that to 0, whatever the solution to this is, will make you divide by 0, right? So we can do a little algebra, and I get x equals 5. Now be careful, the domain is not x equals 5. The domain is all values. Here's one way to write it, kind of directly. X cannot be 5. It's called set builder notation. But we won't really, I'll accept this if you give it to me. But when you do your homework, my labs always likes interval notation. So here's the equivalent in interval notation. You start at negative infinity. So really it's every single real number except 1. Okay, so you get to 5 and then you skip it. And you'll get used to doing that. So these two things are equivalent. X can't be 5, or negative infinity to 5. Do not include 5. That's what we use parentheses for, 5 to infinity. Okay. Now, what's the concept here? I explained this a little bit before. You can't take the square root of a negative. Completely different thing. So that means this has to be non-negative. Algebraically, that's greater than or equal to 0. That is different than this concept of not dividing by 0. Students mix these two up all the time. Because like one, the algebra required, one is you set equal to 0, the other one you use an inequality. So they look kind of similar, but they're two different concepts. Can't divide by 0, have to be greater than 0, greater than or equal to 0. Two different concepts. So just try and remember, if it's a fraction or what's called a rational function, set the denominator to 0, solve, exclude those solutions. In this case, it's just one solution. For this one, we say it's a square root or any even root, this would apply, like if that was a 4 or a 6. It's the same concept, and we say it has to be greater than or equal to 0, and then you solve the inequality. And here's my domain. All right, set builder, and then how would you write that in interval notation? It would be start at 2, go to infinity. Infinity always gets a parenthesis, and in this case, because 2 is allowed, I use a bracket because that's in the set. Right? I'm allowed to plug in g of 2. What happens? I get the square root of 0, which is a real output, 0. Anything in this set I can plug in. Like you can test it if you want to be sure. You say, oh, what's g of 10? Square root of 10 minus 2, that's the square root of 8, which is a real output. Right? If I plug in 1, I'm going to have a problem. 1's not in my domain. This is my domain. 1 is not in my domain. Give it a test. 1 minus 2, that's the square root of negative 1. That's a problem. That's not a real number. Okay? So we have those two cases, which we'll get to more complicated functions later, like the log function and the exponential function. But for right now, I'm probably just going to focus on rational functions, divided by 0, root functions, square root of a negative, and then other functions where there is no problem. If it's not one of those scenarios, then the domain's all real numbers for functions that we're working with so far. It's a linear function. It's no problem. If you wanted to graph it to see, it looks something like that, right? Which means it goes right and left forever. This is a quadratic function. Any polynomial domain is all real numbers. So anything that doesn't have a root and doesn't have a fraction and just is like a polynomial function, just has x to integer powers, everything's okay. I can plug in whatever I want. Okay, so these next three all have issues. So pause the video a minute, see if you can figure them out. What's the domain? For C, I set the denominator to 0 and solve, and I leave that out. So the domain is in interval notation, everything but 1, and that's what it looks like. This one, I just take this, just don't think about it too much, just take whatever's under there and make an inequality out of it. So if I solve that, I get 2x is greater than or equal to 5, which means x is greater than or equal to 5 halves. It's a fraction, but no worries. Some of you might be tempted to write that as like 2.5 or 2.5, but we like improper fractions, so they're good. In other words, you can just leave it like that. That's the exact value. We start at 5 halves and we go to infinity. Everything greater than 5 halves. Oh, here's a tricky one. I got to set this denominator to 0 and leave out the solutions. So we haven't talked about factoring yet, which we will. But it is a prereq. So you've done it before, so let's do a quick review. You might remember factoring. You say, okay, this is a kind of a basic case. You might remember the question is two numbers that multiply together to give you that and add together to give you that. So to multiply to get 3, it's just got to be 3 and 1. And then to add to be -2, I think that would have to be negative and that would have to be positive. And then our final step is to set each factor to 0 and solve. And then we've done the solving part. But now we got to do the domain part. Remember, don't say the domain is x equals 3 and x equals -1. Say the domain is everything but those two numbers. So start at -infinity, go to -1, skip it, go from -1 to the next bad value, 3. Oh, kind of ran out of room here. That should be written all in one line. And then you skip 3 and go to infinity.